Hello, can anybody hear me? Hello?
Hello.
Yeah,
Okay,
I can hear you.
very good. Very, very good. Let's come over here. No, let's come over here. Let's go to my website. I've got a couple more minutes. A couple of minutes. One more minute. Let's see. Who's here? 13 people, all excited to come early. They came early, want to know a little bit about networking. Okay, let's see who's here. Come on, baby. Oh, wrong one. Come over here. Very, very nice. And then there's some people that are going to be fashionably late, of course. Okay. Let's move this over here. Come on. Come on, baby. One more minute. Okay, let's see. Okay, let's the learning begin. I got some nice early submissions for this homework 9. And I wanted to share with you one of them from Patrick. Patrick does typically nice work, but I wanted to show you what a very good assignment would look like. Okay, let me bring up his code and then run. Where's the, oh, Jesus, this has got to go. This thing has got to go. I'll come down here. Let's show you. Okay, and there's his GUI. Pretty neat, huh? Okay, this GUI makes me want to buy his app. Okay, the program behind the GUI is the same as what everyone else produces, but what everyone else produces doesn't look as good as this. So you should probably start thinking about making your GUIs. What can I do to make my GUIs look better, prettier, nicer? This is what your task is going to be. You know, I can't teach you that. This is stuff that you have to take the bull by the horns and, okay, let's try this. He's got gradients all over the place here. Okay, and all he did was he looked at my sample app style .css and he tweaks it here and there and to get that look. It's all programming is nothing more than try something. If that doesn't work, try something else. And it's the person that tries the most often. A person that doesn't do anything isn't going to produce a good GUI. So then I have to ask, why do you want to do this if you don't want to do anything? Also, I've got a couple of submissions that did not send me all the files necessary to run the app. Okay, the whole idea is you have this gist. This gist can take multiple files. All I should be able to do is download the zip file and drag all the files into a project. I run it, I look at it, and if I can't get that to run, if I have to change the file names to .java, if I don't see a CSS file, you know, I'm pissed off. Okay, it'll happen to you too as you get older. You just get pissed off, okay, that people aren't doing the right thing. So don't piss me off. Do the right thing, okay? Don't be, a lot of people are immature. I guess because you're young. As you get older, you start learning that maybe Professor Silvestri made some sense, okay? Do the right thing, send all the files. I didn't think I had to say that. I thought it was assumed. At any rate, that's enough of that. So I just wanted to applaud Pat for doing some nice work. Okay. Let's take a look at some networking now. Networking. Let's come over here. I already posted the next homework assignment. Let's take a look at it. Now you don't have all the knowledge to do this. Hopefully by the end of this video you will. Okay, so it's due next Friday. And so there's a server running on the CS machine right now as we speak. And that server is just a normal program that's running in the background. It's sitting there waiting for people to connect to it. Typically, this is much like what you'd already do with websites. If you create a website, the website is sitting there waiting for people to connect to it via the client. Now, when you're dealing with networking, it's not enough to know the address of where that program is running. Right now, it's at cs.stick.edu. Of course, that represents an IP address. Okay. In fact, I don't even know what the IP address is. I forgot what it is. Nor should you really care. Okay. You just care about the name. People remember names. They don't remember numbers. Okay. So that's one facet of networking, but also a computer is capable of running thousands of programs simultaneously, okay, concurrently. And if it's a network program, you have to specify a port number on that machine in order to determine how a client would connect to it. Because if you have thousands of programs, those thousands of programs run, and they're all network capable, those thousands of programs need to have a way for clients to distinguish on that machine which program you want to connect to, and that's the port number. And so there's theoretically 65,556 different ports, 2 to the 16th, different ports on a computer. The ones that are less than 1,024 are what are called well-known ports, and you have no access to those well-known ports. Those are standard ports that you can't use ever. And anything above that you can use, provided someone else isn't already using them. Okay, and so on this computer, I know that there was no other port running on the CS machine that's allocated port 5,000. So if some other program did, and I tried to use port 5,000, my program would die immediately, because it makes sense. Once somebody allocates a port number, you can't claim it. Okay, the first come first serve on a port number. So if you're dealing with let me just ask you a question. You should know this answer. Okay, because you're the internet generation. When I when I go to this website, cs.stick.edu, what port number is this browser connecting to? Does anyone know? No one knows?
80.
Port 80. Port 80, very good. Port 80, okay? And if I put in your URL, you probably never do this, but I could have done this. That's how you specify the port number on your client. This is the server name and then the port. I want to connect to that. It should give me the same. Uh-oh, something happened. HTTPS, okay. Come on, baby. I don't want the HTTPS. I want simple HTTP, and that should work. So port 80 is HTTP, and port HTTPS is 443. These are the port numbers you pick up as you start doing more networking. The idea, but people don't do that because it's guaranteed that if you use HTTPS, it's automatically going to use that port 443, unless you do something, unless you're running a server that's using this protocol on a different port, then you have to specify that port number so that your client can connect to it. So any questions before I continue? Anything going on here? Okay, nothing. Everybody understands that? That's good. That's good. Okay, let's go back. There's a server running on that thing, port 5,000. Okay, it is designed to generate lottery numbers for a client. Still love those lottery numbers. Hoping to win, but I don't think I'm going to win. This homework involves adding to the GUI that you either created or are creating by tonight, the code necessary to obtain those lottery numbers. See, when you push that button, right now you're just going to print out the contents of the drop-down box and the radio buttons. But ultimately, you're going to send that information to my program there on the CS machine. And then the CS machine is going to validate what you sent me. Because just because your GUI does what it's supposed to do doesn't mean that there aren't any rogue Chinese actors out there trying to destroy my program, hoping that they bring down the CS machine and they take it over. Okay, you need to servers always have to validate the input that comes on there. And we'll talk. And actually, you really don't need to worry about that on your end. See, there's two parts when you do networking. You have to worry about the server end and then the client end. Okay, right now, all you care about for this assignment is the client end. And the server is going to take a look at the information that's sent to it and then decide if that information is good or not. All right, so you got the protocol. Now, what a protocol is basically an accepted convention that decides how the client and server connect to one another. First off, there has to be, the server is going to be written in a certain way to accept information in a certain order. The client has to be written to give it that order. Otherwise, you violate the protocol. Okay, so let's continue a little bit before we continue here. The server will use scanners and print writers to do its communication with the client. See, that's why we had to learn Chapter 12 stuff. Right now, you are masters of Chapter 12. You know scanners, you know print writers. And so that's how the client is going to communicate with the server, and the server is going to communicate with the client through these objects right here. And we're going to use simple server and simple client code in the network sample as examples of how to code. I'm going to go over that. Right now. Okay, so here's how the server basically works. Server sits there, waits for a connection, doesn't take any CPU, nothing. Just sits there, lays dormant until a connection is made. All right, so somebody in Siberia decides they want to connect to my server. Once a connection is made, the server is going to wake up. It's going to create a scanner and a print writer from the socket it made from the client. Now, I got to talk about what sockets are. Here's what a socket is. Very simple. Very, very simple. Okay, so here we have, here's the server. Here's the server right over here. And on this machine, you can think of a socket as a way to plug your client into the socket here. This is called a socket. And a socket is it consists of two things. The socket consists of an IP address and a port. That's what a socket is. Okay. And so then here we have the client over here. Say it's in a different continent, different world, halfway around the world. And the client also, see, the client connects to a server socket, but the client uses its own socket, which consists of its, every client has an IP address. And unbeknownst to you, because you probably didn't really think about it, when your browser connects to a website, the browser allocates a port number on the client that is available. Usually it's a big number like 14,000 or something. It's not, you don't really care what the port is. You just, the only thing the client cares about is there's a way for me to access information on the server. I know its IP address. I have to know its port number. And so what you do is you create a connection, a network connection, okay, to the server using that port, and it's called a socket. You're making an actual socket. The server then will accept the connection and then create a socket connection. This is the internet, to your client. And you know, the client, see, when you make the connection, the server knows the IP address of who's connecting to it. It also knows the port number that's the client is working on. The server also makes a connection to the client using these two pieces of information. And once you've got these two sockets, these are low-level sockets. Sort of think of it as like the operating system. Okay, Java will then take these sockets and convert convert those to scanners and print writers. I never did this. You don't communicate with a socket directly. You communicate with the scanners and print writers that are connected to those sockets using those two, you know, the standard methods of scanners, next int, next line, that kind of stuff. Print writers have print line and print. Okay, so that's the beauty of networking. This networking here, you have this really complicated maze of networking here that's buried in the operating system. Java from day one, Java 1 said, well, I'm going to convert those sockets to scanners and print writers, and then the program will just use those things and communicate accordingly. So, any issues with what I said? Any problems with the high-level view? Now, you don't really have to get into the nitty-gritty of these sockets. All you care about is just knowing that a socket is essentially an IP address and a port number. The server has to somehow advertise what that socket is. Maybe you send an email to your friends. Maybe you advertise on a web page. That people have to know. Somebody in Siberia has to know that this server is running. They won't know unless you tell them how to connect to it. But once they connect to it, the server knows the origin of the connection, knows its IP address. It also knows the port number, so that the server can connect back to the client. So that's the issue. That's what happens when you're dealing with networking. Let me minimize this in case we need it. Okay, let me make this a little bit bigger. Control plus. Nope, Command plus. Can't do Command plus. What's going on here? Command plus. Can't make it big. Oh, there it is. Command plus. Okay, so once a connection is made, the server is going to create scanner and print writers on top of those sockets. It's going to read, the scanner is going to read whole lines. Okay, so in other words, it's conceivable that you could read, the client could send an integer to the server. The server can read that integer using its scanner next int. But I think it's just going to be easier to just send whole lines. And what I mean by that is when the client sends information to the server, it's going to send it through a print line. And a print line, just send it one big string. The server is going to read that information using a scanner. See, okay, this is something I need to, let's come back here. Let me just show you here. Okay, if the client is going to send something to the server, the client is going to use a print writer. Okay. To send information to the server. Okay, to send information to the server. The server is going to get that information using a scanner object. And the print writer is going to use a print line. And the scanner is going to use a next line. These are the methods that you're going to use. And so when the server wants to send something to the client, when it wants to send something to the client, the server is going to create a print writer. So the print writer is going to send information. The client is going to use its own little internal scanner to read it in the opposite direction. That's why each of these things, the server has a scanner print writer, and a client has a scanner print writer. Okay, so what do you think? Okay, so the scanner will read info coming from the client, and the print writer will send info to the client. Yeah, yeah. Once the client establishes connection to the waiting server, okay, this is important. This is part of the protocol. Once the client connects, and you don't really have to worry about timing issues too. That's another thing with the high-level networking. You don't have to worry about, you know, the exact time that a connection's made and whether the server is ready to accept information. The client can just send information. Just send information, and the server will just buffer it if it needs. If you have a slow server, the server is just going to sit there, and once it needs that information, it'll grab it from the buffer. You don't have to worry about any timing issues whatsoever. Okay, so once the client establishes connection, it's going to send the following info. So picture you press that generate button. Immediately, you're going to send a string that represents the number of quick picks. You're going to send it to the server. Okay, the next line it's going to send is the string representing the game to play. See, so you have to say, well, that's kind of the basic information that server needs. You know, how many quick picks you want, and whether you want, lucky for life or mega bucks or whatever, because each of them has their own little rules. Okay, now I don't even know if you really need this. It really depends upon your GUI. Before generating any lottery numbers, error check these lines. Yeah, okay. I don't really think you need this too much because you're using a combo box, and the combo box automatically has the number strings in there. And the only thing that you might need is on the radio buttons. If you don't have one that's already defaulted, what happens is the information you get from that set of combo boxes is null, and you really can't send null to a server. So the idea is don't send a server something that you know is going to be bad. Why waste the internet connection? So just remember the first line represents the number, and the second line must be one of these strings, case sensitive. Case sensitive, Powerball, no space, Mega Billions, no space, Lucky for Life, no space. Also capital letters, lowercase letters, that's important. All right, so there's the client. Client sent that information to the server. Now some magic happens on the server. The server's going to read those lines, okay? Now, just because it gets those lines, you can't assume anything on the internet. You can't assume that they're using a legal client. The server has to check to see if the information it got is valid. All right, so it does some error checking. If the server ever receives anything that's abnormal, okay, an abnormal could be sending the word Tony for the number. And Tony's not a number, so of course, so it should just send, the server should return a -1. That's what it does. The first thing it returns is a -1 on its own line, and then another line that describes the error, like Tony's not a number or something. The client is then going to read that -1 and display the error message on its GUI. Okay. Now, if all's well, okay, the server is going to generate lottery numbers, and you don't really have to care. You really don't care how it does it. You really don't. That's the beauty of the separation of powers. Okay, you don't care how it does it. It just knows that you're going to get back some valid lottery numbers. It's going to return a line to the client that represents the number of quick picks generated. The server limits the number of requested lucky numbers to prevent the denial of service. Here's what I'm talking about. If it receives, if the client, this has got to be an if, I got to change it. If the client receives 1 billion lucky numbers, it requests 1 billion lucky numbers, clearly there's a problem. Okay, somebody's trying to hack the server. Because if the server tried to generate 1 billion lucky numbers, it's going to burn up. Okay, it's going to sit there, and You can't have the server just wasting electricity. Okay, so the server is going to respond, but with a maximum of 10. That's it. So you have to limit. Otherwise, you're just going to be, you have what's called a denial of service. Nobody else can actually connect to it while it's trying to generate those 1 billion numbers. So it could take 10 minutes. Okay, and in those 10 minutes, the server is just going to sit there and reject any other communication with some other client. So if everything goes well, okay, the server sends back the number 10, then what follows is going to be the lucky numbers, each on our own line. So 10 lucky numbers comes back, okay, and all you got to do is read those numbers, those strings, and put them into your text area, okay. And I just told you you don't really care about this so much as these are the ranges of Powerball, Megabucks, and Lucky for Life. But that's what's going to happen. So what do you think? Does it make any sense high level?
Yeah. Do you have the program ready so that we can see how?
It's ready. It's running right now. It's on the server running right now.
No, the actual, the one that you coded so that we can see how it actually goes.
Well, everything you need to know is a simple server, simple client, and that's what we're going to talk about now. Okay. You have that code. You have that code. So let's keep that. Okay, let's minimize this. Minimize that. Close that. Simple client. Simple server. Okay, let's still worry about the client, I suppose. Simple server, huh? Okay. So I'm going to do all my development work on my local machine. First off, don't even worry about making any connections while you're doing your development stuff. Well, geez, you need to connect to the server to do your program. So what I'm doing here is I'm developing both the client and the server. And so it's probably best to do everything locally and then prove that it works locally before you update. So before you go ahead and try to update a server. But you're not even going to do any server stuff, so let's not worry about that. Okay, here's my development. Let's see. Okay, I'm going to try to allocate a scanner because see what I'm going to try to do is run make a program that adds. I pass it 2 numbers, and I have a server that sits there, accepts the 2 numbers. And then what it does is it also gets the operation. So I pass it 5 and 3. I type in 5 and 3. I pass it the number the plus. It sends 5, 3, and plus to the server. And then the server will add those 5 and 3 to come back with 8. See, we need all that technology to do that. Okay. So this is what we're trying to do. We're trying to send some server a couple of numbers, and then send it in operation. And then the server is going to read those numbers in operation and then return an answer. Okay, that's what we're trying to do. All right, so right now, I need to create a socket connection. I need to create a socket connection to the server. Okay, local host in my development is your local machine. You don't have to worry about that. Local host is this IP address right here. That's the IP address of your home machine. Okay, so there better be a server running on port 5012. Otherwise, it's, you go to run this, it's just going to sit there and get upset. It's going to get upset. So right now, I'm not even going to bother running it because, well, I suppose I could run it. Let's run that here. Okay, so there's my server running. Okay, so now if I go to run this, let's run this thing. So actually I got 2 programs running. Okay, so I actually got 2 programs. Yeah, I don't think you've ever done this. Okay, Eclipse lets you run multiple programs at the same time, and the way you access it, yeah, they're right there. It doesn't tell you to. So one of these little icons here. See, I got simple server and simple client, and I can switch between the 2. Okay, up, 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 up. Simple client. Let's go to the client. Okay, it's this little icon over here that lets you switch between the running programs. So I'm going to send operand 1, 5, enter. Operand 2, 3, enter. Let's make this computer work. I'm going to put a divide by symbol. Okay. Ooh, boy, look who'll come back. Success. Where'd it go? Did I just lose it? Oh, wait a second. Oh, it's terminated. Okay. See, I sent a 5, I sent a 3, I divided. The server actually did the division and came back with that. And then once, apparently I don't have this in a loop or anything. But my client just dies. Client just dies right there. So there you go. We just did some networking. Okay, so I create the socket. If execution goes line 27, it'll print success. That's just a little, where's that? Yeah, right there. That P string is just a simple print line. Okay, so success. Now the next thing the client's going to do is convert these, this is your client socket. Client is a socket right there. The client is a socket. The next thing you're going to do is create scanners and print writers. And the way you do that is on the client socket, you execute this method right here. Get input stream. An input stream is basically a bunch of characters that come in. See, the scanner is going to read from this input stream its information. And the way you get that from the socket is there. That's just going to return an input stream, just a stream of characters that the scanner is going to use and read. Likewise, the output, see, from the point of view of the client, when the client wants to send something to the server, it's going to send it using a print writer, but it's going to send it through an output stream. So client.getOutputStream is the way you send out characters low level. Print writer is going to send those out to this stream, and those stream of characters is going to go through and be sent to the server. And so from then on, you're done. The networking is done. Okay, what you're going to do now is say, well, this is just normal. This is your scanner connected to the keyboard. Okay, so when I typed in 5, okay, 5, you got to send out lines, whole string of lines. So that 5 has got to be converted to a string. That's why you see that double equals or double quotes. And very important, you got to flush. Okay, once you send that print line that information doesn't go immediately out to the server just because you printed it out, unless you flush the buffer. You got to put that flush in there. A lot of, things don't work very well unless you flush. All right. So now it's guaranteed that server sitting there is going to grab that information. It's going to grab that information, and now it's going to sit there because the server now needs another piece of information. It'll sit there, wait for you to send another one. And so we grab another piece of information right over here. Operand 2. That gets sent out, flushed. Now we need to clear our keyboard. We need to clear the keyboard. Now, because we want to send out a string, and we want it on my screen here, I got to make sure my divided by is on a separate line. So I cleared my keyboard. Enter my operation. Read the operation as a line. I mean, it's only a 1-character line. Okay. Since it's already a string, I send that right to the server, flush. Okay, and so if line 49, according to the protocol, if the server is written correctly, it has all the information it needs. So it's going to sit there and wait until the server sends back the answer. Input that next line. It's going to, from the input, it's going to get its information from the input. The input's connected to the input stream from the server. And then we print out the answer. And that's it. Then I guess we close out the the connection, because this is just a catch and a finally. And actually, if everything goes well, none of this, other than the finalies are important. Okay, everything has got to be closed. See these things right here. Okay, if everything goes well, you've allocated a bunch of resources on your client. You need to close them, and then you just basically do this. Okay, close the input, close the output, close the client, and you're now a good citizen on your computer. So what do you think? Oh, I think I got a version 2 that doesn't need a finally, because yes, version 2. Okay, look at version 2. See, it's a lot cleaner. There's no more finalies. Okay, because first off, this won't work. Okay, because there is no program running on cs.stick.edu port 5012, but there is on the local computer, local host. See, what's happening is allocate these resources. See right there? Try allocating those resources. And it's basically the same thing. Create a socket, create the scanner, create the print writer. Okay, if execution goes into line 23, you're going to have connection. It's going to be the same thing. And once you're done with this process, the system will automatically close all those resources that you've allocated up there. Okay, so that's actually a nicer version of the program. And you really should catch exceptions, though, because this is the internet, and stuff always happens. Somebody pulls your internet wire while you're doing your connection, that kind of stuff. An exception is going to be thrown, and then you're going to print out some information as to why that happened. Okay, so what do you think? File, save this. Let's save that. What do you think? Let me run that. The server's still running, I believe. Yeah, the server's still running. Client 2. Run it. Run it. Here's my client. Okay. Again, it's this little button right over here. Okay, display the selected console. Okay, let's make it 45 point. Okay, 3.4. Let's give it some real numbers to work with, and we're going to do a multiplication. Enter. There you go. It's got to be. That looks right. There's your answer for that. So right now, believe it or not, you don't need to even worry about the server. The server, I mean, you have everything you need to do this assignment right here. All the stuff that you think that you need is right there. Okay, but I'm going to talk about the server so that, see, when you have a server, you don't display the server code and make that available to the world. All you do is you provide what's called an API, an application programming interface. And I'm telling you what the API is right now, the protocol, okay? And so how the server does things is immaterial. So, but I'm going to go over the server, the simple server, not the server that's running on port 5000. So what do we got going on here? Okay, let me just do a quick scan. I forgot. Okay, okay. I run the program. Okay, I run the program, main. This is the thing that's running on the server. I run server. Okay, run server comes over here. Okay, and run server is this. Okay. Now there's something called a server socket that's a little bit different from a socket, but we'll talk about that right now. Try a bunch of code. Just try a bunch of code. Okay, and let's see what that code is. This is just little informational numbers. Creating a server socket. Okay, server. Okay, what happens there is a server socket is a special socket where it's designed to sit there and wait until a connection is made to it. That is different from a client socket. A client assumes that the server is already in existence. A server socket, and you got to give it the port number, in this case 5012, okay. So 5012, And a lot of stuff can go wrong on the server end. If someone already allocated 5012, you're immediately going to be, an exception is going to immediately be thrown. But since you're in control of your own machine, that shouldn't be a problem. Line 25, you'll get success. And servers are basically one big while loop. Okay, while true, do something. What you're going to do is sit there and wait for a connection. First thing, wait for a connection. You see, notice it looks almost like the client. Socket, print writer, scanner. Okay, we're going to sit there and wait for an exception. So on the server socket, you're going to run that method called accept, and it just sits there and waits for some client to connect to it. Okay, right now, that server is still running. See, that server is still running right there. It's waiting for a connection. Okay, because it's sitting there on the accept. Now, some client comes in, and when that client comes in, what happens is you've accepted that connection, okay? And that connection is a, where did it go? Right there, oh, right there. Is a socket connection to the client. So now the client, you now have the IP address of the client, you now have the port that client's using, and now we try to create a scanner and print writer from that connection. Okay, now you got to make sure you do things in a certain order. What the client sent it was the 2 lines of operands. So that's why I read a line from the input. See, the scanner. Yeah, I'm reading a line from that scanner. I convert it to a double, do the same thing for the second line, convert it to a double. The next thing I read is an operation, which is 1 line. I switch on that op. If it's a plus, there's my answer. If it's a minus, there's my answer. You got that. If I send it anything else as an operation, then I send back, I throw an exception called bad operator. Okay, now make sure you connect. See, answer is a number. I need to convert that to a string that gets sent out. See this string, line 68? Line 68, I send out the string. I flush it out to the server. No, to the client. I flush it out to this client. Okay, and that's the protocol. If something bad happens, then I send out an error message. Okay, I send out an error message, and I've got to make sure I close and especially with a server, you can't keep resources open. You need to close your connections, and that's basically the code for that simple server. So what do you think? Does this make a little bit more sense? It's even better. You don't have to write the server. I'm just showing you, if you want to run this code on your local machines, there it is. You can try it out. You can experiment with this multiple console thing that we have here. And you'll also notice that all you need to specify is the port number. The server is assuming you're running this program on your laptop. It's going to use whatever IP address is on your laptop. Chances are it's going to be the local host, so you don't even have to specify the IP address. It just will use whatever IP address your server is running on your laptop, and just got to specify the port number. Now, what's server 2? I bet you server 2 is basically the same. Yeah, server 2, because this stuff here, server 2, I hate doing this stuff when you don't have to, finally, where you have to clean up all your resources at the end. That's automatically done here. You've seen this. Okay, try. Accept a connection. Allocate sockets from that connection. The rest of the stuff is the same. Okay, if execution comes here, you automatically close your resources. So what do you think? Your head spinning? Is anybody awake out there? 16 people. Anybody awake?
So we can do math on our local machine. We don't have to set up anything.
On your local machine, that's what I'm doing here.
Okay.
Forget cs.stick.edu. Pretend it doesn't exist. You have code called Simple Server or Simple Server 2, one or the other. Let's close this up. Close it. Let's close all these things up. Okay, that's been terminated already, the client. Close up. We're done. Okay, let's take a look at the simple client. I'm going to run this with no server, Run this, run it. That's going to die. Good, 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 because there is no connection refused. Connection refused is because there's no server there to connect to. Okay, you've got to run your server before you can run your client. And so the nice thing is, I already have the server running on the CS machine. Now something might go awry. Okay, if you're start coding this thing like now, over the weekend. Okay, and don't code it Friday at 9 o'clock and you find that the server's down. Too bad. Okay, what can I tell you? I'm not going to sit there and I'm going to watch my Bill Maher on Friday night. Okay, I'm not going to sit there and wait for it to see if there's error messages on the server. This weekend, try to make a connection to the server, see if it works. I think that I coded the server pretty bulletproof, but you never know. You never know. So let's try server 2. Server 2. Run server 2. Okay, good. Server 2 is there. Server 2 is there, and oh, which one was that? Where did it go? Now let's try another one. Server 2 is running. Let's do a client. Okay, client is running. Okay, so you have to have, before you can get this icon, you have to run 2 programs. There's my client. Okay. That's my operand 1. Okay, operand 1. Okay, of course. What's going on here? Of course, input mismatch. Okay, here's what happened. I sent gibberish to the server. The server is sitting there waiting for a number that got converted, that was supposed to be converted to a double. But that gibberish can't be converted to a double. An exception gets thrown. Okay, so I send back, I send back this here. An exception gets thrown over here. My answer is basically the message that says that input mismatch. I send that out, flush it out. That's what the client did. That's what the client did. It got back the message. Okay, run this again. All right, let's give it what it's supposed to have. Let's see, 4 and 5, normal numbers, and then I'm going to type in Tony. Bad operator. Bad operator. That got sent because I said, well, geez, it's not one of those operators, so I send the runtime exception, and then what happens, I come here, and that message is bad operator that gets flushed back to the client. All right, and so now meanwhile the client did this. Let's do this again. Let's run it again. Let's run client 2. Client 2, 6 and 7. Whoa. Oh, I just screwed something up, damn it. Edit, undo, typing, undo. Control Z, Control Z, Control Z. Up. Local host. See what happens. Gotta watch what you're doing. Okay, operand 1, 5, 6 times. Everything went well. While we're here, to give you a full appreciation of the server, doesn't matter which one with the server. This server really doesn't do anything fancy, okay? Let's pretend it takes 10 minutes for the algorithm to compute the sum. Okay, let's pretend it takes 10 minutes. So what happens is the first person that connects accepts the connection. We created our input outputs. This is the server end, and now it sits there for 10 minutes. All right, your code is sitting over here for 10 minutes. Okay, another guy wants to connect. Well, the other one can't connect, okay, because your server can only connect when it's trying to execute line 28, but you're sitting there trying to do some compute-intensive calculations, and the second person is just going to sit there and get an error message. Okay, that's not a very good server. Okay, so what do you think the solution to that would be? Well, this might be a little high level. Okay.
Threading.
Threading. Man, it's like looking in the mirror right there. Okay. Threading. What that means is this is a single threaded server. What that means is there's only one flow of execution in this server. Okay. It takes 10 minutes for this code to run on there. What you want is to have multiple threads of execution. It's a very simple thing to do. Simple threaded server. Now your client doesn't have to be threaded, but your server does. Okay, and it looks kind of complicated, but I feel I need to show you this. Okay, look at the run server. Look at the run server over here. The run server is kind of short and sweet, isn't it? Okay, just kind of short and sweet. It still has to have a socket, port 512. In fact, you know what? I'm going to run this. Let's close the server. Close the server, and that's it. That's it. Okay, I'm going to run simple threaded server. Okay. Uh-oh, what did I do? What did I do? What did I do? Connection refused. Okay, let's run this again. Let's run this again. I must have did something. Okay, I don't know what happened there. Okay, I'm running this guy right over here. Okay, it's sitting there. Look at this while loop. You're always going to have a while loop. If it's a server, it's going to sit there and wait and wait. And if there's a connection, great. I get a connection. I spawn off another thread. Okay, I spawn off another thread of execution. Okay, based on the connection I received. I start that thread, I come back. So even though behind the scenes, this starts off a thread of execution that takes 10 minutes to execute, that's fine. That's fine. You still have this thread that sits there and waits for to accept another connection. That other connection, let's say another guy comes in, wants to run it, no problem. I start another thread of execution, start that. So now I've got two threads of execution connecting, doing 10 minutes of compute time. Okay, comes back, it sits there. See, this loop is tight and quick. Okay. And it's going to accept another connection there. Now, what happens is the thread connect is just another class right here, thread connect. You can call it Tony if you want, but it has to extend thread. It has to extend thread so that you create your own little threads of execution. Once you start a thread, okay, this basically, a thread connect is basically a thread, and you start the connection, the run method gets called on that thread. And doesn't this look like the same code? Doesn't that look like the same code we just looked at? Okay, the run gets called when the threads get started. And see, when the thing that you have to understand too is that thread connect has a constructor. You passed it the open connection to the client. See, the server.accept will return the socket connection to the client. I pass that connection to the constructor. The constructor is just going to take that connection and store it until you start it. See, this class will have that connection stored, and then I'm going to create the print writers and scanners based on that connection, and the rest is the same. And the nice thing is you could sit there for 10 minutes on that thread okay, the main server is still going to be sitting there waiting for another connection. That's the way I wrote the server on the CS machine. All right. So what do you think? Are we masters of networking? That's all you need to know about networking. That's it. That's what I just showed you there is everything. I think there's a chapter in the textbook. I think I'll make that available. Yeah, I'm going to make it available through Revel, so that if what I'm doing for you isn't working for you, he goes into it in much more detail. And what he does is good work. But I'm just skimming the surface as to what you need to know. You need to know something about servers and sockets and the like. And I think that's it. So the next major topic that we're going to talk about is this database stuff. And so I think what we'll do is we'll have a class on Wednesday, not Monday, Wednesday, because I want you to concentrate on doing all this networking stuff. But on Wednesday, I'll do a class. I'll send out an invitation where we talk about database stuff, and we'll leave it at that. All right? How's everybody? What do you think? What do you think? Okay, the guys that really need to know it aren't here. Okay, good. No problem. All right, we'll see you on Wednesday then. All right? Have a great day.